Lightning round got a little slowed down, but here we are doing number 9, practice problem for module 15. Okay, so Martin, please read number 9 to us.
This
Whoops.
is not in page 9. Moving around the bookmark. Also not 9. There's 9. What is the equation for the acid ionization constant of HCN?
Okay, so in order to do this, it's important to remember our polyatomic ions, which you can find on page 288. Okay?
Yeah.
As you know, this is not a polyatomic ion, but it is a hydrogen ion. The other one you need to remember is cyanide, Cn negative.
Yeah.
Okay? So these are the two ions that you need to be familiar with. One is a polyatomic ion. The other is the single atomic ion. So the equation for the acid ionization constant is going to look like what?
It's going to look like sort of like the K thing.
Okay, so HCN
Ka equals
is going to be in equilibrium with
H negative plus Cn negative.
I think you're mistaken about something.
No, H plus, right? Of course. And then we just put them into the rate constant equation.
Okay, so what's that going to look like?
It's going to be the concentration of H times the concentration of Cn over the concentration of HCN.
Okay, and none of these are squared or cubed or anything because the coefficient of them all is 1.
Okay, on to 10.
Number 10, the same video. Keep
What
going.
is the equation for the base ionization constant of SO4 2 negative?
Okay. Okay, so the base ionization is 288, but right now we're going to just, how do we go about finding that?
Back in 9.
It's page 288.
Oh. I meant the polyatomic ions.
Yes, it's on page 288. I said for the 4th time.
Oh, I see.
Thank you. Okay, what are we doing with this?
Well, we're doing the same formula we did last time.
Excuse me. So what happens in this base reaction? What's happening? How are we going to make an equation?
Well, we should look at the polyatomic ions, I think.
What's it going to be reacting with?
O, S, and O. Yeah. O2, which means S2.
Just a moment. I'm not sure they explain it as well in the text as they could, but in On Your Own 1512, where they ask, what is the equation for the base ionization constant of pH 3? explain in the answers on page 521 in the answer for 1512. The base ionization reaction involves having the base accept an H positive from water. Okay, so we need to take our SO4 2 negative and have it accept 2 hydrogens from water. Does this make sense?
Yeah.
Actually, it's not going to accept 2 negatives. It's going to stay H2SO4
Yep.
negative. Okay. All right, so what do we do?
Well, which we
SO4 2 negative plus. Yeah. And how's it going to be? It's going to be aqueous, right?
Yeah.
Plus
water. Hydrogen, water, liquid. Of course, it's liquid.
So we're going to end up with OH negative, right?
Yeah.
And what else?
HSO4 negative. And then we put that in the equation. So that's concentration of.
This is K subscript B, right? Is going to be the concentration of HSO4 negative times the concentration of OH negative, and we can ignore the water because it's
liquid.
Oh, these are aqueous. Remember the concentration of SO4 2 negative.
2 negative. Yep.
Okay.
And we're done finally, at last.
Thanks, friends of chemistry.